Assignment number 3, page 71, problems 31 and 32.
In problem number 31, Sakazi is learning to ride a bike without training wheels. His father pushes him with a constant acceleration of 0.5 meters per second squared for 6 seconds, and then he continues at 3 meters per second for another 6 seconds before he falls. What is Sakazi's displacement? Solve the problem by constructing a velocity time graph for his motion and then compute the area underneath the graphed line. When constructing a velocity time graph, time is always on the x-axis, time will be in seconds, and velocity on the y-axis, and that will be in meters per second. So at time equals 0, Sakazi must be stationary. Then his father pushes him with a constant acceleration, and at the end of 6 seconds, Sakazi is going at 3 meters per second. So at 6 seconds, he's going at 3 meters per second. So 0, 0 is a data point, and 6, 3 is a data point. Sakazi continues at 3 meters per second for an additional 6 seconds, so that brings us to 12 seconds, and at that point he loses his balance and falls. So the graph of Sakazi's motion looks like this. It is a trapezoid. So what's the area under the graph? We can divide it into a triangle and a rectangle. So Sakazi's total displacement is the area of the triangle, which would be 1/2 base, which is 6 seconds, times the height, which is 3 meters per second. Area of the triangle plus the area of the rectangle. Well, the base goes from 6 to 12, so the base is 6 seconds again, and the height is again 3 meters per second. So 1/2 of 6 is 3, 3 times 3 is 9, seconds times meters per second gives you meters. 6 times 3 is 18, seconds times meters per second again gives you meters, so the total displacement is 9 plus 18, or 27 meters. Sakazi went a total of 27 meters before he fell down. In problem number 32, you start your bicycle ride at the top of a hill. You coast down the hill at a constant acceleration of 2 meters per second squared. When you get to the bottom of the hill, you're moving at 18 meters per second. You pedal to maintain that speed. If you continue at this speed for 1 minute, how far will you have gone from the time you left the top of the hill? So let's draw a diagram. You're at the top of the hill, you coast down, and then you continue along the flat ground for an additional minute. They don't tell us how long it takes to come down the hill, so when we get to the bottom, we're going to call that time equals 0 seconds. And you continue for 1 minute. Well, 1 minute is 60 seconds. We need to use seconds. So, question can be broken into 2 parts. What is the displacement coming down the hill when you're accelerating, and what's the displacement across the level ground when you're going at constant speed? Okay, so you start at the top of the hill. We have to assume you were stationary when you got on your bike, so B initial is 0. When you get to the bottom of the hill, you're moving at 18 meters per second, but you're going in the downward direction down the hill, so that's negative 18 meters per second. They tell you the acceleration is 2 meters per second squared, but again, you're going downhill, so that's negative 2 meters per second squared. how far did you go down the hill? Is what we're trying to find. Time is missing. So for the first part, we need v final squared equals v initial squared plus 2ad. So negative 18 meters per second quantity squared equals 0 squared, which is 0, plus 2 times negative 2 meters per second squared times d. So negative 18 squared is 324. Negative sign goes away. 324 meters squared per second squared equals negative 4 meters per second squared times d. So 324 meters squared per second squared divided by negative 4 meters per second squared equals d, which equals negative 81 meters. So the negative sign just means he was going downhill, but his total distance traveled is 81 meters down the hill. What about the horizontal portion? Well, he's going at 18 meters per second. It's no longer negative because now he's no longer going downhill. He's going across, so we can lose the negative sign. But he's going at constant speed, so d equals v times t, the first equation that we learned. So v is 18 meters per second, and he's going for 1 minute or 60 seconds. So in the horizontal portion, the distance he has traveled is 1,080 meters. So total distance, not displacement, but total distance traveled is 81 meters plus 1,080 meters, and that sum is 1,161 meters. His total distance traveled from the top of the hill is 1,161 meters. Problem 18. A golf ball rolls up a hill towards a miniature golf hole. Assume the direction uphill towards the hole is positive. A. If the golf ball starts with a speed of 2 meters per second and slows at a rate of 0.5 meters per second squared, what is the velocity at the end of 2 seconds? So the initial is 2 meters per second, positive because it's going uphill. What is the velocity after 2 seconds? V final is what we're trying to find. They tell us the acceleration is 0.5, but it's slowing down, so it's negative 0.5 meters per second squared. Time is 2 seconds, and distance, we don't know. That's what's missing. So V final equals V initial plus AT, 2 meters per second plus negative 0.5 meters per second squared times 2 seconds. V final is 2 meters per second minus half of 2 is 1, so minus 1 meter per second. So the answer is 1 meter per second. At the end of 2 seconds, the golf ball will be rolling at 1 meter per second. Positive, so it is still rolling uphill. Part B, what is the golf ball's velocity if this continued for 6 seconds? So it's the same equation. The initial was still 2 meters per second. Acceleration is still negative 0.5 meters per second squared, but now the time is 6 seconds instead of 2 seconds. So we've got 2 meters per second plus half of 6 is 3, so plus negative 3 meters per second. 2 plus negative 3 is negative 1 meter per second. At the end of 6 seconds, it's rolling at negative 1 meters per second. So how would you interpret motion of the golf ball? It's rolling uphill, it's slowing down, starts at 2 meters per second. At the end of 2 seconds, it's slowed down to 1 meter per second. Well, it keeps going uphill. At some point, it stops, and then it begins to roll downhill. And by the time 6 seconds has passed, it's rolling at 1 meter per second downhill. That's what the -1 means in part B.